There's a liquid sitting inside your kitchen right now. It costs less than $1. And it does something to glass that a billion-dollar automotive industry has spent 40 years making sure you never figured out. When applied correctly, in the right ratio, at the right temperature, this mixture bonds to the silica molecules in your windshield at the atomic level. Water doesn't bead on it. Water flees from it. We're talking about visibility so sharp, so instant, that some drivers have reported turning their wipers off completely at highway speeds in moderate rain. Now ask yourself this: why have you never heard of it? The answer isn't that nobody discovered it. The answer is that the people who discovered it had no financial incentive to tell you. And the people who did have a financial incentive had every reason to make sure you kept buying a $12 bottle every few months, applying it wrong, watching it streak, and coming back for more. The windshield treatment industry generates over $300 million in annual revenue in the United States alone. Rain-X, launched in 1972, built an empire on a single premise: that you needed their chemistry, their formula, their brand. But the underlying science, the actual molecular behavior that makes water repel from glass, that science is older than the company, far older, and it's reproducible with ingredients that have been available to ordinary people for over a century. This knowledge wasn't destroyed. It was simply made inconvenient. Welcome to Forbidden Wilds. This is where we open the vaults that industry's buried, not with explosives, not with lawsuits, but with something far more effective: distraction. If you're here for the first time, understand what this channel is. We don't deal in conspiracy. We deal in chemistry, history, and the quiet, persistent gap between what science discovered and what corporations decided to sell you. Today, we're going inside the automotive glass industry, and we're pulling out something they'd rather you never found. You know the feeling. You're on the interstate. It's 11 p.m. The rain starts. Not heavy, not a storm, just that miserable low-grade drizzle that turns every oncoming headlight into a white smear across your entire field of vision. You hit the wipers, they smear. You hit the washer fluid, it smears differently. You slow down because you genuinely cannot see the lane markers. And somewhere in the back of your mind, you remember that you meant to buy more Rain-X, that you applied it 2 months ago and it worked for about 3 weeks before it started streaking. This is the cycle the industry designed, not because the chemistry wears out that fast. It doesn't have to, but because their version of the chemistry, the diluted, shelf-stable, margin-optimized version, is engineered with a specific shelf life on your windshield. The version we're about to discuss is not. The year is 1903. A French chemist named Edouard Benedictus is working in his Paris laboratory when he accidentally drops a glass flask. The flask falls to the floor, but it doesn't shatter. It cracks, yes, but it holds its shape. Benedictus investigates and discovers the flask had previously contained cellulose nitrate, a polymer solution that had evaporated and left a thin, nearly invisible film coating the interior of the glass. That film had bonded to the silica structure of the glass at the surface level. He had stumbled onto something that the scientific community would spend the next 4 decades fully understanding. The way certain organic compounds bond with glass doesn't just coat the surface, it integrates with it. Fast forward to the 1940s. The U.S. military is developing aircraft canopy treatments for combat pilots flying in Pacific weather systems. The problem is identical to yours on the interstate: precipitation obscuring vision at critical moments. The solution they land on involves alcohol-based silicone precursors applied to the polished glass surface under controlled conditions. The results are classified as operationally significant. The formula is not released to the public. 40 years later, a commercial version of a distantly related compound enters the consumer automotive market. They call it Rain-X. But here's what they don't tell you about the difference between what the military used and what goes into that orange bottle. The original formulas used a 2-step process: a surface preparation stage, followed by a bonding agent. The consumer product? Single step, optimized for convenience, shortened molecular chain length, designed to be easy to apply and easy to wash away. Here is what is actually happening on your windshield when a water repellent works correctly. Glass, at the molecular level, is a silica network, silicon and oxygen atoms bonded together in a non-crystalline matrix. The surface of glass is covered with what chemists call silanol groups, silicon atoms with a hydroxyl group attached, essentially a tiny hook. Water repellents work by replacing those hooks with hydrophobic, water-fearing, molecules. The classic commercial approach uses siloxane compounds. They attach to the silanol groups, and their opposing end is chemically nonpolar, meaning water molecules, which are polar, cannot form bonds with them. The water rolls off. Now here is the critical part that the consumer industry obscures. The strength and durability of that bond depends on 2 things: the length of the molecular chain being attached, and the preparation of the glass surface before application. If the glass surface still has oils, minerals, or prior product residue on it, the siloxane compounds don't bond to the glass. They bond to the residue. That's why your Rain-X stops working. Not because the chemistry fails, because it was never touching the actual glass. The DIY method we're about to discuss starts with the step the bottle skips. In 2019, researchers at the University of Michigan's Surface Science Laboratory published findings on the comparative durability of hydrophobic glass treatments under standardized UV and precipitation cycling. Their data showed that commercially available single-stage silicone treatments showed measurable degradation in contact angle, the scientific measure of water repellency, within 90 days of application under normal outdoor conditions. Two-stage treatments using an isopropyl alcohol surface preparation followed by a Carnauba silicone hybrid compound showed contact angles that remained stable past the 180-day threshold. A 2021 study from Germany's Fraunhofer Institute tested similar preparation protocols on automotive-grade glass and found that the surface preparation stage alone, before any repellent was applied, increased adhesion durability by 340%. 340% from a cleaning step. That single statistic tells you everything about why the consumer product skips it. Let's do the math plainly. Rain-X, owned by Illinois Toolworks, is a product line generating hundreds of millions in revenue across its full automotive glass category. The average consumer repurchases windshield treatment products every 8 to 12 weeks. That repurchase cycle is the business model. A product that genuinely lasted 6 to 12 months would not destroy the brand. It would destroy the repurchase frequency. And in consumer product economics, repurchase frequency is everything. This is not speculation. This is the documented incentive structure of every consumable product category in automotive care, from motor oil to air filters to wiper blades. The industry does not sell you solutions. The industry sells you treatments. There is a meaningful difference. A solution solves the problem once for a long time. A treatment requires you to come back. Here's exactly what you need and exactly what you do. Gather 70% isopropyl alcohol, under $2 at any pharmacy. White distilled vinegar, under $1. Pure Carnauba wax paste, under $8 at any auto store, and it will last you years. And microfiber cloths, which you likely already own. Step 1 is stripping the surface. Mix equal parts isopropyl alcohol and distilled white vinegar. Apply to your entire windshield with a clean microfiber cloth using firm circular motions. This dissolves silicone residue, mineral deposits, and prior product buildup from the glass. Work in sections. The glass will squeak slightly when it is truly clean. That squeak is the silanol groups exposed and ready to bond. Wipe completely dry with a separate clean cloth. Step 2 is applying the Carnauba wax. Apply a thin, even layer of Carnauba wax paste to the glass using a clean cloth. Work in overlapping sections. Let it haze. This takes approximately 4 to 6 minutes at room temperature. Do not rush this stage. The hazing indicates the wax emulsion is separating and the Carnauba compounds are contacting the glass surface directly. Step 3 is buffing. Use a clean, dry microfiber cloth and buff the haze away with firm circular pressure. The glass will look almost unrealistically clear. Step 4 is the test. Pour a small amount of water on the treated section. Properly treated glass will cause the water to sheet and roll immediately. Not bead, not pool. Sheet. Total cost of materials for a full windshield treatment, approximately $3. Estimated duration with proper surface prep, 90 to 180 days under normal driving conditions. A mechanic in rural Pennsylvania who runs a small independent shop outside Allentown began testing this protocol on customer vehicles 2 years ago after a conversation with an older body shop restorer who had been using a variation of it since the 1980s. He documented 12 vehicles over a 6-month period. His notes, shared in a regional automotive restoration forum, describe the following. All 12 vehicles showed sustained water repellency past the 90-day mark. 7 of the 12 were still performing measurably at 150 days. 3 vehicles treated in winter. And when glass surface temperatures are lower and the bonding conditions are more stable, we're still repelling water cleanly at 180 days. One of the vehicle owners, a long-haul driver with a heavy rain commute through the Poconos, reported turning his wipers off at speeds above 45 milli-an-hour during light rain for the first time in 20 years of driving. He said the rain looked like it didn't know how to land on the glass. That is what proper molecular bonding looks like from the driver's seat. We will not pretend this method is magic. That would make us no better than the industry we're critiquing. Heavy rain still requires wipers. This treatment improves visibility dramatically in light to moderate precipitation. But in a true downpour, the physics of water volume exceed what any surface treatment can manage alone. Application also requires a clean, dry surface. Attempting this in high humidity or on a windshield that isn't completely dry will reduce bonding significantly, and temperature matters, with 60 to 80 degrees Fahrenheit being optimal. Carnauba wax is a natural compound, not a synthetic silicone, so in extremely high UV environments like the desert Southwest or high altitude climates, reapplication may be needed closer to the 90-day mark. And this does not replace your wiper blades. Degraded blades dragging across any treated surface will strip the treatment prematurely, so inspect those first. With all of that stated honestly, the core claim holds. Proper two-stage treatment using alcohol vinegar prep and a Carnauba wax significantly outperforms single-stage commercial silicone products in both clarity and durability, at a fraction of the cost. Here's the thing about buried knowledge. It doesn't die, it waits. In old military manuals, in restoration shop conversations, in the quiet notes of mechanics who learned from people who were there before the industry decided what you were allowed to know. The chemistry that makes water flee from glass is not a trade secret. It was never proprietary. It is written in the language of atoms, in the silanol groups on the surface of every piece of glass ever made. The only secret was the surface preparation step. The only lie was the omission. And now you have it. Apply it this weekend. Test it. Share what you find with someone who drives in the rain. And if someone tells you it won't work, ask them who told them that and what they're selling. If this is your first time at Forbidden Wilds, hit subscribe. The vault stays open here. We'll see you in the next one.